Today we would be discussing the 2001 physics MCQ paper, and we'll discuss on how to approach the exact answer in detailed manner in this particular video. So let's start with the first question. I've shown you the 2001 paper, A-level paper, at the right hand corner of my screen. First one, EV, also called electron volt, is a unit of. The correct answer is EV is known as the electron volt. So voltage is a measurement of electron volt, is a unit of energy. Second question. A sound with intensity 10 to the power minus 12 decibels, or Wm minus 2, is defined to have an intensity level of 0 decibel. Decibel is the intensity level. So just the intensity is Wms minus 2 is the unit. The intensity level of a sound of intensity of 10 to the power minus 8 Wm minus 2 is. The way we need to calculate this is that the short method. It says that if 10 to the power minus 12, then the decibel count is 0 decibels. So we have 12 here. Since thereby we can substitute this in an equation. Decibels equals 10 log to the base 10 I over initial intensity value. So here the initial value is already given. The new intensity value is 10 to the power minus 8. So substitute 10 log base 10. New intensity level is 1 into 10 to the power minus 8 divided by 1 into 10 to the power minus 12. So here, once we calculate this, we get 10 into log base 10, 12 goes above, that means 1 into 10 to the power 4. So base log 10 to log 10 goes off, that means 10 into 4 is 40 decibels. Question number 13. So the answer for that is 40 decibels. Question number 3. Two particles A and B have equal moments, but the velocity of the particle B is 4 times that of A. The ratio of kinetic energy of A over kinetic energy of B is. Here, let's write down separately the kinetic energies of A and B under two different categories. So the kinetic energy of A, Ek of A equals half ma Va square. Moments equal, only the velocity is changed, right? Only the velocity is changed. So kinetic energy of B, half mv vb squared. So if this is particle A, particle B, they have equal moments. Moment equals mv. Moment equals mv. Here also mv, here also mv. But the velocity of B is 4 times of A. If velocity of A is va, B is 4va. Okay. Thereby, we can substitute for the ratio given, that is kinetic energy of A. Kinetic energy of A, Ek of A divided by kinetic energy of B. So kinetic energy is half into kinetic energy equals Ek equals half mv squared. We already know that. So here kinetic energy of A we can write half into m into v, okay, va, into velocity of A is also va, divided by half into, because the moments are equal, we can write here also ma, into velocity of B is 4 times that of va, 4 times that of A, that means 4 into 4va. So all of these cancel off and finally we get 1 over 4. Thereby Ea, or kinetic energy of A over kinetic energy of B, equals to the ratio 1 over 4. That's how we approach that particular answer. Question number 4, a uniform, so the answer for that, I'll underline the answer in our question. Question number 4, a uniform circular plate of radius 2r has a circular hole of r cut out of it as shown in the figure. The center of gravity of the plate with the hole is most likely to be found at. So 2r is the whole circle. Question number 3, if this is the circle, there is a hole cut from here. Uniform circular plate is of radius r. Radius r. So this should be a bit larger. Let's think this is r. And this also is r. The center of gravity. So once you hold, you obviously can't hold this radius is 2r, right? Radius is 2r. Here the diameter is 2r, but sorry, I made a little mistake here. So here in this circle, this is r, radius r. So the diameter, altogether it is the diameter of the whole circle, big circle is 4r. Its radius is 2r, and the circle which is cut interior in its internal side of the right hand side, that is the radius is capital R. Center of gravity of the plate with the hole, so it obviously cannot be inside this territory. It should be out of this. It should be more towards the left hand side, more towards the side where there is more mass, right? Hence it cannot be E here, it cannot be E. it cannot be A either, because once you hold, just imagine placing this structure with the hole on top of your finger. So which place is most suitable so that it could stay stable as much as possible in its maximum? I think my guess should be just D. Just imagining that that structure is placed on your on one of your fingers in your hand. So it cannot be C either, cannot be B either. So it should be D. It should be the center of this area. This side, it should be the center line position. So that is D. So answer should be D. Question number 5. Consider the following statements made about infrared, ultraviolet, X-rays and radio waves and gamma rays. So, here when considering this particular question, all given rays are electromagnetic waves, right? We obviously know that. So, the A statement should be correct, right? All of them are electromagnetic waves. Just imagine the electromagnetic spectrum and you can answer this. So, second B, all of them travel with same speed in free space. Free space in the sense is a vacuum. Free space is a vacuum. They also have the same velocity as 3 into 10 to the power 8 ms minus 1 in this space. So, the B statement is also true. A true, B is also true. See, radio waves have the longest wavelength. Radio waves have the least frequency, but it has the longest wavelength, lambda. So, the C statement is also true. So, what could be the correct answer? So, the correct answer is all these statements are correct. All the statements are correct. Okay. Just give me some time to drag this out here. And this particular part below that. Right. So in that question, the answer is 5. Question number 6. The mercury column rises in the mercury in glass thermometer when temperature is raised. The most appropriate reason for this is, here because the temperature rises, the mercury and the glass bulbs also expand. But for mercury to travel upwards along the capillary tube, it is indeed essential that the glass expands less than that in which the mercury expands. So, thermal expansivity of mercury is higher than that of the glass. So, the glass expands less than mercury when heated. So, the correct answer is 4. Question number 7. The electrical energy stored in 1 microfarad capacitor connected across a 2-volt cell. So, considering capacitors, that's a main equation to calculate the energy of capacitance. Okay, so energy of capacitance is calculated using this particular equation. E equals, I didn't write the question number, it's 7. E equals half CV squared. You have to remember this particular equation. So, and substitute it here. Half into C, capacitance is 1 microfarad. Here 1 into 10 to the power minus 6 should be there. Then the voltage is given as 2. That means 2 into 2. So 2 to 2 cancels off. The correct answer is 2 into 10 to the power minus 6 joules. Check whether there is such a answer. Yes, question answer number 3. 8th question. The mass and the radius of Earth is capital M and capital R respectively. The escape velocity of a rocket of mass M on the Earth's surface is. Question number 8. So what do you mean by this so-called escape velocity? It is the minimum velocity. So I'll define this, what the escape velocity is, the exact definitions. You should be able to keep them in mind. Escape velocity is the minimum velocity. Minimum velocity at which object must be thrown over the Earth's surface to prevent it reaching the Earth's surface again is called Earth's escape velocity. That is called the Earth's escape velocity. Okay, that is called the Earth's escape velocity, because this is common to each and every planet in space. So this could be applied to other planets as well. So considering the Earth, I mentioned this particular definition. So it has to be the escape velocity of Earth. So here what they ask is to find this particular escape velocity in terms of the symbols already given. The main equation that we use with regard to escape velocity is 2gm divided by r. That's the radius. G is the gravitational constant, m is the mass of the particular planet, and r is the radius of that planet. Here it's the Earth. So just directly you can substitute V equals 2gm divided by r, the whole square root. There's a way which you can obtain this using the energy conservation principle. I'll mention that method too as well here. By using the energy conservation, if you are stuck with memorizing the equation at that time, you can use this way. Total energy at A, just draw the diagram. Draw a diagram like this of the planet, and then there's a mass. The planet is here. This is the planet, and this is the that is the rocket. Rocket is at this orbit. So this is the planet Earth. So this is the radius, and this moves in a velocity. Okay. So energy at A. I'll mention two positions. At infinity, the position is B. Energy at A equals energy at B. At energy, there is a velocity, that is half mv square, plus we know that potential energy, gravitational potential energy is mv. So potential we can write m into minus gm divided by r, that is the potential. So at infinity we don't have a velocity, we don't have potential energy. This is the kinetic energy, this is the potential energy. So by simplifying this equation, gmm divided by r, and finally you get m to m cancels off, then v subject v squared equals 2gm divided by r, thereby v equals root 2gm divided by r. This is our final answer. So question number 8, the answer is 2gm divided by r whole thing square. Question number 9. A proton is fired at an atomic nucleus X. Which one of the following parts shown in the diagram is not possible for a proton? So the nucleus of an atom contains positively charged protons. So when a positively charged proton approaches it, we can guess from our initiative thinking that there is a repulsive force acting between them. So what has happened in the path S is that there is no repulsive force acting. It's indeed going towards that. So that cannot happen. So what they ask is which diagram is not possible for a proton. So the suitable answer is S. Answer 4. Question number 10 is a logic gate question. It is a logic gate question. I'll have to get this down, like this. So question number 10. There are several types of gates that you'll be learning under the topic electronics, logic gates. So this kind of a gate, we know that most of the ICT students who done IT in your A levels, they know that this is the AND gate, and this is the with the curve like scenario, then it's a OR gate. Then if you have this not available concept, there's a NOT gate connected to it, then that's a NAND gate. And here for a OR gate, if there's a not available or not concept, then that is a NOR gate, so on. So here we don't need that much of knowledge to answer this particular question, but of course yes, you see that this gate here is the gate that I have drawn here, right? So this can be drawn if you fix a NOT gate. The NOT gate is something like this, okay? It has only one input. This is the NOT gate. That means if there is input A, then the output F will be, if there is 0, you get 1. If you give 1, the output will be 0. That's the scenario, the opposite. So here if you connect the NOT gate to the OR gate, NOT gate to the OR gate, that's the same output that you'll be getting. This exactly is this. So the correct answer for this is 5. So just add the NOT gate from here, NOT gate from there, sorry. So up to now we have already discussed 10 questions in your 2001 physics MCQ paper. So I'll come up on with the next 10 questions in another session. So Keep in touch with my YouTube channel where I'll be uploading all the MCQs up to the latest exam that was held this previously. So the more you do MCQs, more you are touching MCQs, more you'll be able to score better marks in your exams and ace your results. So thank you for watching this video. Please subscribe my channel. All the best. Have a nice day and good luck.